test.js within the folder test. Now, in order to create the file, we'll access the folder structure of our structure, access the C drive, and locate the folder that we created, test. Within this folder, we'll create a file, and the name of the file will be test.js. We'll navigate back to our IDE and run the command dir to explore the content of the folder test. We can notice that the Windows added the extension .txt to the file, so we'll rename the file to convert it into a JS file, and to do that, we'll run the command rename test.js.txt, test.js. We'll run the command dir again, and this time we'll observe the file has been converted to a JS file. Let's clear the screen for a better view. Now the next task is to install the test framework that we'll be using, which is Mocha. And in order to install Mocha, we'll run the command npm install followed by -g to ensure it's installed globally, followed by Mocha. npm will connect to the npm JS repository, pull the installation files, and get it installed. Finally, Mocha is installed, and we can confirm that we're provided with the version of Mocha, which is 5.2.0. Since it's installed globally, we can run Mocha commands from anywhere. Now the next task is to initialize the folder test as a node package, and for that, we'll run the command npm init. When the command executes, we'll be prompted with certain questions for the package. The first one is the package name, and we'll name it as test. We'll use the default values for the version, description, and entry point. For the test command, we'll be using Mocha. Then we'll use the default values for the Git repository, keyword, author, and license. Finally, we're asked to confirm if the values are okay. We'll confirm yes by pressing the Enter key on the keyboard. So now we've initialized this particular folder as a Node.js package. Let's clear the screen again. The next task is to load the project folder into our IDE so we can write the test cases and execute the tests. And to do that, we'll click the File tab from the top navigation panel, select Open Folder, locate the folder, and click Select Folder. So now the folder test is accessible from the Explorer panel, and it currently contains two files. The first one is package.json, and the other one is test.js. The file test.js is currently empty because we haven't specified any testing element. When we access the file package.json, we'll find an interesting element which is scripts, and it contains test, with Mocha as the testing script to indicate that Mocha should be used to test applications. Now we'll write the first test case, and it will be written in the file test.js. In line 1, we'll declare var assert equal to require followed by assert, since we want to utilize assertions. In line 2, we'll use describe to build the test group. Within describe, we'll specify array to indicate what object we want to test. And in this case, we want to test array. The second argument that we will pass is a callback function, which will be called in order to execute the test cases. Within the callback function, we'll specify the test cases, and the first test case should be bundled in another group. So in line 4, we'll specify describe and specify the function index of, which is what we want to test. So this is our test group, which is specified to test the function index of. And now this test group will also have a function, which needs to be specified. Within the subgroup which we have added using describe, we'll specify another test case. So in line 7, we'll specify it. It's taking something else, so let's correct that. Then within it, we'll add some context. For example, should return -1 when value is absent. So when there's no value present in the array, it should return -1. Then we'll add a function within which we will conduct the actual test. For example, in line 9, we specify assert.equal. And within assert.equal, we'll specify the expected value, which is -1. followed by the actual value of an array. For example, we're building an array with the value 10, 20, and 30, followed by index of, for which we'll pass an index which does not exist. We've specified the expected value, which is -1, and we've specified a function which will get the actual value. So we've written our test cases. We've created the groups using describe, and describe contains a subgroup which is responsible for aligning all the test cases that are specified to a particular case. Now we have to align the specifications in the editor. We can simply click on the light bulb icon and select Fix All Auto-Fixable Problems. Not all the problems were fixed, so we'll click on the light bulb icon and select Fix All Auto-Fixable Problems again. And this time, it's come to a state where we can run this test file. Let's save this file with all the specifications. Now, in order to run the test file, we'll need the terminal, so we'll access the View tab from the top navigation panel and select Integrated Terminal. Using the terminal, we'll run the command to execute the test file. So the command includes npm, followed by the scripts, which was added to package.json. The script is test, and it will invoke Mocha to execute the test. When we execute this command, Mocha will start running the test cases, and the output indicates that the test has paused. So this is how we will be using Mocha to generate test cases and execute the test cases. In this video, we will explore and elaborate the file manipulation capabilities of Yeoman File. We know so far that a Yeoman generator generates a directory structure, which contains various assets of the framework or the application that we want to build. And the Yeoman File utilities are typically based on the idea of two different locations or contexts that are specifically present on the disk. The first context is the destination context, which is basically the folder where Yeoman will scaffold the application, and it's the user project folder which is enabled for writing. It can also be defined as the current working directory of our Yeoman-based web application, or the closest parent folder containing the file .yorc.json. Now this file takes the responsibility of defining the root of the Yeoman project or application. It allows the user to run all the commands in subdirectories and have them work on the particular project. And the destination context is write-oriented. We can use various methods in order to get the destination context, and then use the destination context to write the resources. The second important context is the template context, and this context is basically the folder where we can store the template files. And this context is read and copy-oriented. We can overwrite the existing templates using certain methods that are provided by Yeoman API. Now let's explore the role of an in-memory file system in Yeoman. Yeoman by default is very careful when it comes to overwriting user-specific files. So whenever a write takes place on a pre-existing file, it goes through a conflict resolution process, in which it validates every file write that overwrites the content of the particular file. Now in order to handle this, Yeoman uses in-memory file system, which takes the responsibility of getting the data written in a file to an in-memory file system. The file system is shared among all the composed generators that are a part of the current Yeoman application. And the in-memory file system internally uses a synchronous file system API to write the data to in-memory. Now the in-memory file system is typically used to share the context, which helps resolve write conflicts. And any in-memory file system will contain three important components as illustrated in the sample figure. The first one is user space, followed by kernel memory, and secondary storage. Now the secondary storage is where the blocks will persist. The kernel memory takes the responsibility of managing conflicts by maintaining pre-processed open data with the system-wide file table. So whenever there's a read, the user space locates the same from the kernel memory, using the index, and the index finally ends in the secondary storage to pick the data. Now let's explore the file manipulation capability of Yeoman, which is facilitated using the Yeoman file utility. So Yeoman exposes all the file methods on a pointer, which is this.fs. And this.fs is basically an instance of mem.fs editor, which provides various methods that we can use to manage the files. Some of the methods provided by mem.fs include read, readJSON, write, delete, and copy. We can pass certain elements like file path, contents, and context to these methods. Now let's explore how to implement the file system using the sample code block. Let's assume that we want to write some data. In such cases, we'll first initialize memory fs1 by loading a module or package called memfs using the method require. Then we will initialize an editor by loading the module memfsEditor, following which we will initialize a storage by creating a storage using memory fs1.create. Now after we've created memory fs1, which is an instance of memfs, we'll create a storage. To create the storage, we'll be using editor1, which is an instance of memfsEditor. Call the function create and pass the storage so we can bind the storage with the editor. Finally, we will write some data to the file test.js and pass the value that we want to write to the data. So by using these three important components, memfs, memfsEditor, and storage, we'll be able to bind the storage with the file system editor, execute writes to write the data to the in-memory file system, and store it on the disk. In this video, we'll demonstrate how to use file operations to manage files in Yeoman. In order to manage files, to ensure that the right files are created or copied when a generator is used to build an application, we need to customize the generator. For this demonstration, we'll create a custom generator and illustrate how files are managed in a generator. We'll begin by installing the generator called generator itself, and to do that, we'll run the command npm install -g followed by the generator name, which is generator itself. npm will fetch the generator from the repository and get it installed. This could take a couple more seconds to complete. Now after the generator is installed, the next objective is to generate an application which will be of type generator. So we'll change the directory and move into the root directory using the command cd/. Let's maximize the terminal so we can get a better view. Now we'll create a directory using the command mkdir and the name of the directory as Generator Skillsoft App. Let's move into the newly created directory using the command cd generator skillsoft app. It is essential that we use the prefix generator, otherwise they will not be treated as a generator. Now we can generate the custom generator and customize the structure using various file operations. And in order to do that, we'll run the command yo-generator. When the command executes, we'll be prompted with certain questions to prepare the custom generator. The first question is regarding the name of the generator. We'll use the default name, which is Generator Skillsoft App. We can add a small description, say, this is FileOps Test Project. For the homepage URL, we'll specify www.skillsoft.com. We'll use the default values for the author's name, author's email ID, and author's homepage. For the keywords, we'll add test. We don't want to send coverage report to coveralls, so we'll say no. Then for the GitHub username or organization, we'll specify Skillsoft Jenkins, which is our GitHub username. And finally, the license will select ISC, then press the Enter key. The command will continue executing, and it will create the required directories and run npm install to manage the dependencies. This could take a couple more minutes to complete. Finally, the custom generator has been successfully installed or generated. Now we have to launch the project directory or folder into our IDE, and to do that, we'll access the File tab from the top navigation panel. Select Open Folder, locate the folder, and then click Select Folder. So now the folder is accessible from the Explorer panel, and it contains various essential files. In a Yeoman generator, the files are various types, and they can be classified into configuration files, application files, and so on. To manage files and add custom files, we'll access the folder titled Generator, within which we'll find the Templates folder, which in turn contains the file dummyfile.txt. The folder Generator also contains index.js, which basically controls the entire objective of the generator, helps us customize the file structure, and provides capability of managing file programmatically. So whenever someone uses this generator, it's the index.js file which is responsible for completing the tasks. Now, in order to perform file operations, we need to write the instructions in index.js. So assume that we want to write context data or even files. We can specify them in the writing section, which is specified in line 28, which is an essential function or part of index.js. The files that need to be copied from the template to a particular destination will be specified in the writing section. Next, we want to write our own files whenever someone is using our generator. So we'll create a file in the folder Templates. Click on the New File icon and name the file as test.txt. Within this file, we'll add some content. Say, "This is sample content," and we'll save the file. Now we'll access the file index.js to ensure that it's copied in the destination as well. In line 33, we'll specify this.fs.copy. Within copy, we have to pass this.template path with the file name and this.destination path with the file name. So we'll copy and paste it in line 35 and change the name of the file from dummyfile.txt to test.txt. Now we've added our own file, which will be used in order to copy the context of the file whenever someone uses our generator. Click on the light bulb icon to fix the prettier problem with our code. When this customized generator is used by developers to scaffold applications, it will copy the file content from the template path, which is test.txt, and it will copy it to the destination. We'll click on the light bulb again to check if there are any other fixes that we can apply. Let's ignore it and save the file with the changes. Now the next objective is to make the generator available for the other users, but before that, just make sure all the files are saved. Then we'll access the View tab from the top navigation panel and select Integrated Terminal. Using the terminal, we'll use the command npm link. Now the objective of link is to link the generator with the global node modules. Now let's use the generator to check whether it creates the file which we have specified in the generator or not. We'll change the directory and create a new directory using the command mkdir, followed by a name of the directory, for example, app4. Then we'll change the directory to app4. In order to test whether the generator creates the file, we'll run the command yo followed by skillsoft app. When the command executes, it'll scaffold the application using the declarations made in Skillsoft app. We get a pop-up question asking if we'd like to enable this option. We'll confirm yes. We'll observe that it's creating the files dummyfile.txt and test.txt. And test.txt is a new file that we asked Yeoman to scaffold when it is creating the application. And this confirms that the file test.txt is created when we use the generator. So this is how we'll use the file operations to manage the generator file structure and ensure that the files are copied whenever the generator is used to build an application.